Hello? Hi everyone. Let's continue with the course on HCI storage. Previously, we introduced the basic requirements for storage in the future intelligent era, and the trends for its future development. So, what specific conditions do we need to meet? In this lesson, we'll mainly look at these topics. That comes first. The most basic requirement is reliability, which must be achieved. Meaning high reliability. Here, it mentions 99.5%, but actually 5 nines isn't too much, because this is for a single device. So 5 nines here is already considered quite high. But in fact, after we add anything to our cloud, that is, after we add it to our cloud storage, we actually have a lot. As for the cloud platform, the reliability of its cloud storage has reached 99%, with 13 nines behind it. But this isn't an exaggeration, so why does it have such confidence? It's actually because the advantage of cloud storage lies in what? It's all about how easy it is to back up, right? It's very convenient. Because the storage capacity is really huge, backing up is also very convenient. And backing up doesn't just mean simply copying a file within the same data center. That alone can't fully achieve high availability. The backup methods mainly include things like remote disaster recovery. Remote disaster recovery means that there are 2 different data centers involved. And these 2 data centers are also a certain distance apart. Not just right next to each other. They are hundreds or even thousands of kilometers apart. The 2 computer rooms can also back up each other. So if one data center fails, it basically won't affect the other data center. This is actually a key method to ensure our data's high reliability and availability. So that's the first point. The second point is large capacity. Large capacity actually means our storage units, right? When it comes to disks, we're all talking about storage in terms of terabytes, right? Our disks are measured in terabytes. But even if you fill up a server with disks, it's still pretty unlikely that you'll reach a large capacity, right? It's basically very hard to achieve. EB level storage. It's almost impossible to reach that level. But as long as we do what? We create a cluster. The left distributed storage can reach an EB level for cloud storage. Here, the conversion unit for each B level is 1024. So here is it. As long as we have some cluster type, deployment storage, we don't have to worry about insufficient capacity. In fact, we don't need to worry about the problem of sufficient capacity. Then, the third point is high performance. It's not enough to just have enough capacity, right? You store a lot of content, but you want to read it, right? The reason why we store content and data is to be able to better read and manage these data. So, what is the key point of high performance? It is caching includes latency. Caching has to be fast. And latency has to be low. This is one of our... In the future, there are 3 main fundamental points: high reliability, large capacity, and high performance. That's a total of 3 points. Here, aside from these 3 basic points, let's move on and take a look. On top of these 3 basics, we also have hardware, algorithm architecture, and efficient storage. So that's a simple summary of our 3 points. Now moving on, we have data, non-migration, and data collaboration. What do these 2 mean? The meaning of data non-migration actually refers to what? It means that regardless of whether you're dealing with file types, block disks, block devices, or object storage, we can achieve what? They can all be integrated into a unified platform. We can integrate different types of content onto a unified platform, allowing for some fusion between them. This means that different types of content can also interact and merge with each other. What does this include? It includes our intelligence. And here we also have intelligent tiering. This means we can intelligently classify 3 different types of storage: hot storage, cold storage, and warm storage. For cold storage, we can store it on some hard drives. For hot storage, we can directly use flash memory. For cold storage, we can just use hard drives, whether it's mechanical drives or... What can we put it on? We can put it on this. Blu-ray storage. What exactly is Blu-ray storage? We'll introduce it shortly, we'll get to that. using this storage actually. And of course, it also includes our warm storage. What we can use is what we can use. Hybrid storage. You see, we can use different storage methods for different types of data. This way we can do some differentiation. This distinction can help reduce some of our costs. Then, here, compared with the traditional one, what is the advantage compared with the traditional storage? What if we integrate all these different protocols and storage together? Well, in the past, it might take hours to migrate data across protocols, but now, as long as we can integrate these different protocols, and with tiering, we can achieve what? We can achieve computing without moving data. This is what we call data mobility without migration. What does this mainly refer to? It mainly means that we can use this to replace some of the traditional storage methods, or drives. It reduces our latency from milliseconds to microseconds. To wrap it up in one last sentence, actually, there is also distributed storage, including computer nodes, which we can collaborate to expand. Resources are allocated on demand. Hey, what we can ultimately achieve is integrated storage and computing. Well, let me briefly summarize these 2 points. To summarize these 2 points, data fusion is actually the storage of data in the intelligent era. It's not about storing data, but about using data. This is our ultimate issue with data fusion. And then there's AI, right? AI helps us manage storage intelligently. This is a fundamental characteristic of data storage in our smart era, a basic feature. So next, what's the development trend in data? We've actually talked about this a lot already, right? We've covered it quite a bit. You all can take a look at the content in the images. Hey, from our solid state drives, right? From mechanical drives to solid state drives. Right here, from our SAS FCIB to our IP. And then from the era of 86, we move directly to the virtualization era, E, then to the container era, and so on. These are actually innovations in technology, the development of technology, from database applications to distributed storage, hyperconvergence, and then to cloud computing and big data. These are the specific elements we will need for storage in our smart era. Specifically, we're talking about some content that will be used here. The content we cover is actually quite extensive, so I can't give you a detailed introduction point by point because there's just too much information. In the upcoming storage section, we will mainly introduce some of the usage methods for storage, mainly the usage methods of mainstream storage. So this is basically a summary of the development of storage, which corresponds to the content we've covered in the previous few lessons. And then, moving on to the next part. There are 2 special types of storage that I want to introduce to you first, because in the future, storage will definitely have some new developments. For example, right now, there's something called Blu-ray storage. Have you all heard of it? What does Blu-ray storage refer to? It refers to the main scenario we're focusing on is that the storage can last a long time, with a single disk capacity reaching over 100 gigabytes. The lifespan, it can last for 50 years, which is far longer than both mechanical and solid-state drives. Mechanical and solid-state drives typically last about 10 to 15 years at most. Blu-ray storage, on the other hand, is designed for long-term archiving, and it can store cold data for up to 50 years. That's a key feature of Blu-ray storage. And then there's this one. Gold nanoglass, right? This can have a single disk capacity of up to 10 terabyte and a lifespan of 600 years. And the consumption, as for resources, the power consumption is very small and the energy consumption is only 1/10 of our mechanical hard disk. It can also realize the so-called 1,000-year storage, that is, the data can be stored for thousands of years. This is also achievable. This is for the future. Not to mention the future, in fact, now it is already in use. Of course, this has not been popularized yet. It has not been widely popularized yet. but now there are already 2 types of storage, and you can also learn about them. It's suitable for long-term storage. So that's the content for this lesson. If anyone wants to learn about Huawei's cognitive technology or wants to access the Huawei Cognitive Question Bank, please feel free to message me. I can also engage in technical discussions in the comments below the video. Alright, that's it for today. Bye everyone!